Another broad class of problems that are often encountered are the so-called mechanism problems. In these problems, what you will see is that both your starting material and your final product have been provided, and then the conditions have been provided as well. So we can start with a secondary alcohol, and using H3O plus we can get a mixture of products. And this is what experimentally was observed. Now the question is, how did all of these products form? To understand that, we first need to look at our starting material and our conditions and see what kind of first transformation is likely here. And if we look at an alcohol and in the presence of acid, the first thing that will happen is protonation of this alcohol. And once we have this alcohol protonated, then the OH2 group is a good leaving group and it can depart, providing this cation as an intermediate. And this is a secondary cation. Now, once we have this secondary cation, there are several reactions that we're already familiar with that utilize secondary cation. One of them would be elimination, where we have this hydrogen and another molecule of water, the one that just left, can abstract this hydrogen and form this cation to give form this double bond to give us the first of the provided products. Alternatively, the same cation could be attacked, but a different proton will be abstracted, and then the double bond will be formed in this position, which would then lead to the second possible. However, the other products are not as easily explained by this simple reasoning. By the way, this would be a Zaitev's product because it's more substituted, so this would be predominant. But once we have this secondary cation, the cation itself can undergo other transformations other than eliminations. So what we see here is that this cation could easily get stabilized by movement of this hydrogen, and this will be a hydride shift. And now, with this hydrogen in a different position, this will be a positively charged carbon, and this would now be a tertiary cation, which is more stable than the primary. This cation again could give rise to this elimination product, but it could also be subjected to a different kind of elimination, because now we can take away this proton, which will provide us with this. Finally, neither of these two mechanisms still explains the formation of six-membered rings, and this is explained by a different cationic shift. So in our first case, we had a stabilization of this cation by movement of the hydrogen over here, but now we could stabilize the same thing by moving the whole alkyl group. And this would be an equilibrium because we would form a six-membered cation, which is still secondary. But this thing does happen since their stability is comparable. And now we can already see that the elimination of this six-membered ring can put a double bond in this position, or alternatively in this position. And this would explain for all of your all five products of the formed reaction. So in order to solve mechanism problems, you need to be very specific. Don't assume that anything is obvious or evident. It's not. So be very specific. The second thing is that you should show the arrows that show the movement of electrons, because it allows us to track these things. And the third thing that many people often neglect is that the ending point and the starting point are given to you, and so you need to get to your products, which sort of simplifies your reasoning a little bit because you know what we're supposed to end up. Finally, it's important to follow certain general rules. That electrophiles and nucleophiles are clearly identified, the acid and bases are clearly identified, and that the stabilities of different species are easily understood as well. So this will be all for today's lecture. To sum it up, we looked at several different ways to get to alkenes, and then we looked at two typical problems that integrate concept we see so far. One of them is dealing with synthesis, with multi-step synthesis. We're supposed to get desired products from simple starting materials, and the other one is dealing with mechanisms. We're supposed to explain how does a certain set of conditions lead to a formation of a certain product. In our next lecture, we will see how alkenes undergo a series of different reactions. They're actually quite reactive compounds, and we'll see how we can use alkenes to form a whole array of different functional groups as well. Thank you.